Hello viewers, in today's class we are going to discuss yet another important and conceptual problem from definite integrals, right? So here in definite integrals we are going to solve one important definite integral in which the signum function is involved, right? So here the problem is, if this integral is equal to alpha plus beta times tan inverse 1 over gamma, then we have to find the expression, the value of the expression alpha, beta square and gamma cube, right? So here what we will do, we have to solve this integral, right? So let us call this integral as I, and I is from 0 to 2 signum of x minus 1, and we have x square plus 4 dx, right? So now what we will do, we'll solve this integral and we'll find the value of this integral in this form, and then we'll compare both the values and we'll find alpha, beta and gamma, and then we'll calculate this expression, right? So let us start. So now before proceeding further, let us first take the signum function, that is signum of x minus 1, right? So we know from the definition of signum function, so here I am we are making a quick revision of signum function. Then signum of y is equal to plus 1 whenever y is greater than 0, and signum of y is equal to 0 whenever y is equal to 0, and signum of y is equal to minus 1 whenever y is less than minus 1, right? So now using this definition, we can define signum of x minus 1. So signum of x minus 1 is equal to plus 1 whenever x minus 1 is greater than 0, and the signum of x minus 1 is equal to 0 whenever x minus 1 is equal to 0, and signum of x minus 1 is equal to minus 1 whenever x minus 1 is less than 0, right? So here we have taken x minus 1 for y, right? Okay, so signum of x minus 1 will take plus 1 value whenever x minus 1 is greater than 0. It means whenever x is greater than 1, right? And here signum of x minus 1 is equal to 0 whenever x is equal to 1, and here signum of x minus 1 is equal to minus 1 whenever x is less than 1, right? So now we have here the limits, that is 0 to 2. So here we have 0 and here we have 2, and in between we have this point x is equal to 1, right? So now from this picture we conclude that here we have x less than 1, and here we have x greater than 1, right? And when x is equal to 1, then signum of x minus 1 is equal to 0. That is, when x is equal to 1, signum of x minus 1 is equal to 0, and signum of x minus 1 will take plus 1 value whenever x is greater than 1, and signum of x minus 1 is equal to minus 1 whenever x is less than 1, right? So now once we have discussed the definition of signum function, we can now break this integral I as a sum of two integrals, right? The first one is from 0 to 1 and the other one is from 1 to 2, right? So now we can write this integral as 0 to 1, and then we can write it from 1 to 2, right? So when 0 to 1 we have signum of x minus 1. Here we have x square plus 4 dx, and here we have signum of x minus 1, and here we have x square plus 4 dx, right? So this is I1 and this is I2, right? Okay, so when x varies from 0 to 1, from 0 to 1, then obviously x is less than 1, right? So when x is less than 1, then signum of x minus 1 is equal to minus 1. So here we'll have minus 1, right? And when x varies from 1 to 2, from 1 to 2 x is greater than 1. So when x is greater than 1, signum of x minus 1 will take plus 1 value. So here we'll have plus 1, right? So now these two integrals become 0 to 1, and here we have minus 1 over x square plus 4 dx plus 1 to 2, and here we have plus 1 over x square plus 4 dx, right? Okay, so now what we will do, we have two simple integrals, right? So now this can be written as 0 to 1. Here we have minus 1. This is x square plus 2 square dx, and here we have 1 to 2, and we have plus 1. This is 1 over x square plus 2 square dx. And now we can make use of an important result, that is dx over x square plus a square, that is integral of 1 over x square plus a square is equal to 1 over a, and this is tan inverse x over a, right? So here a is 2, here also a is 2, right? So we have minus, we can take this negative sign outside the integral, so we have minus 1 over 2 and tan inverse x over 2, and the limits are from 0 to 1, and here also we have half tan inverse x over 2, because both the integrands are same except this negative sign, and we have 1 to 2, right? So now this expression can also be written as, we can take half outside, we have tan inverse x over 2, and we have the limits 0 to 1, and here we have half tan inverse x over 2, the limits are from 1 to 2, right? And now we can substitute the limits. So here we have tan inverse 1 over 2, and here we'll take x equal to 0 and tan inverse 0, right? And here we have half, we have tan inverse 2 over 2 is 1, so we have 1 minus tan inverse 1 over 2, and now this is minus half tan inverse half, and this is 0, and here we have half, and tan inverse 1 is pi by 4, and here we have minus half tan inverse half, right? So minus half tan inverse half minus half tan inverse half is minus tan inverse half, because minus half is minus 1, and here we have pi over 8, right? So now the value of this integral I is equal to pi over 8 minus tan inverse half. So now viewers, the value of this integral is pi over 8 minus tan inverse half, and the value of this integral, which is I, is also given as alpha plus beta tan inverse 1 over gamma, right? Now if we compare both the sides, what we will get, alpha is equal to pi over 8 and beta is equal to minus 1, and gamma is equal to 2, right? So here we have minus tan inverse half, which can also be written as pi by 8 plus minus 1 tan inverse half, right? So alpha is pi by 8, beta is minus 1, and gamma is equal to 2, right? And now we have to find the value of alpha times beta square times gamma cube. So alpha is pi over 8, beta square is minus 1 square, and gamma cube is 2 cube, right? So this is pi over 8 and minus 1 square is plus 1, and here we have 2 cube is equal to 8. 8 and 8 get cancelled, so we are left with pi, right? So viewers, the value of this expression is equal to pi, right? So viewers, in this class, what we have learned how to solve this integral and how to find the values of alpha, beta and gamma to get the value of this expression, right?